So, and let me zoom in. So here we go, and bit of a spoiler alert. In fact, I'm going to shelve these changes for now. Yes, sure. Here we go. So, first one, we had to, this was the first exercise they gave as part of this interview. It was finding the n largest elements, but actually they asked specifically for 3 largest elements. So write a function that takes in an array of integers and returns a sorted array of the 3 largest numbers of the input array. So this was the exercise. And it has to return duplicates as necessary, which is important to mention, so you don't jump onto the idea of creating a set and then finding the maximum within the set. You have to use the list to keep the duplicates. And here is the input and the expected output. And that's what we need to find the solution for. So let's create a Python file. Let's create a Py file. And then let's try to implement it. So let's say this is the input. And I would suggest renaming it because it's a reserved keyword, as you know. So after you create this, you cannot actually use the input function as before. So I would prefer something like, let's call it array. And let's do find 3 largest. For now, let's do 3 largest, and then we can generalize it. Okay, so find 3 largest. It takes an array, and it returns the result. Okay, for now, let's leave it. So how could we implement this? What do you think?
Using count, like not a count, but like start with, let's say, largest equals 0,
Largest is equal to 0,
and then
0.
iterate over the list. Also, we have to enumerate the list, I think.
Enumerate it. Why?
So we can, so we can add it to that new count. No?
For that, we can add it directly because we are not actually modifying the same list. So we don't have to keep track of the index. But the thing is, we don't just have to find the maximum, we have to find the 3 largest numbers. So the result is going to be of length 3 with the largest numbers. And they also have to be ordered. It has to be sorted.
Yeah. I mean, we can just sort that list and take last 3
Yeah,
numbers.
exactly. Like this would
Like
be, of
slice it
course,
or something, or
this would be the easiest way. -3. So starting from the third to last element until the last element. And then it will just show you the, let's print it. It will just show you the result, which is correct. But at the interview, they said, do not use sort. Do not use the sorted, or do not use sort either, because of course you could also use array that's sort and then just check the array after that. Okay, so what's left in that case?
I mean, we have to iterate over this anyway. So, I mean, iterate from what, like 0 to length -1 of this list?
We can iterate through, and then how do
And
we keep track of the largest elements?
maybe max function,
Yeah,
or we cannot use
actually,
functions at all.
sorry.
We cannot use like
Yeah,
function.
that's the tricky part, because when I mentioned, okay, we can use max function, they said, okay, I mean, I was going to find a maximum, without the max function, and they said you can use the max function, which is really funny to me, because
Yeah.
if they allow you to use max, why they do not allow you to use sort? It's kind of like they're trying to push you in a direction to find it in a way that they want you to find it, which is really strange. But yeah, let's see another alternative. So this first solution was really, I think it's a really efficient and good solution, and it can be easily generalized to not just 3 items. You can also do as many items as you want, but let's see. So for now, let's just stick with 3, but it applies the same generally as well. So what I did at that time was write this while, and basically we had to find the 3 largest, right? So we had to iterate through this 3 times, and we had to remove from the array. So this is where we cannot use a for loop because we are using the array. And if we iterate, wait, I'm thinking. Actually, we can use a for loop. We can use a nested for loop. Let me improve a little bit. We could use a nested for loop. We say for, well, we can actually just use the underscore in range. Let's stick with I because it will be more obvious. Okay. Length of array for j in range length of array. So this will be length of array. This one will be 3. So how many elements we want. And basically every time in each of these iterations, we find the max number. Well, in this case, actually, we do not even, okay, let's say we can use the max function for now to simplify it. If that's the case, we can just find it using maximum is equal to max array. And basically we want to remove that maximum value from the array. But besides that, we also want to store it. So we have a result like this. This is what we are going to return actually. And we add the maximum to the result. So in this case, you have these, and what is the issue?
Not sort.
Yes, it's not sort. It kind of is actually. It's the opposite way. So alternatively, we can just turn it around. That would be one way to handle it. Or if you want to handle it immediately, basically you could do something like result insert, and you insert it to the first position. 0 maximum. Yeah, and now it's sorted.
But
Looks good.
what if it's like we had originally 541, 141 and 17. What if we have 541, 17 and 141? Will this still
You
sort?
mean the order here?
Yeah, like
Yeah, the order doesn't matter in this case because the thing is it's always finding the maximum number. So it always finds maybe I can also open up Xcalibur, or just give me a moment, and then I can explain that better. But basically, if we have this array, okay, let's say like this much. Okay, so we have this array. Every time we have 3 iterations, we find the largest one, we remove it, and we put it separately into our result. And the next step is that we find again the largest one, which is this one, and we put it before this one. And we repeat it until we find all of them. So in this case, we were looking for 3. This is the 3rd largest. We find it, we put it in the beginning. So the order doesn't matter. It doesn't have to be, this array doesn't have to be ordered. This one will be ordered when we do this. But what about the time complexity? It can be a little tricky. So the time complexity, what you have to understand is that the time complexity doesn't necessarily correlate with the performance. You can have the same time complexity for 2 algorithms, and still one could be slower than the other. It just measures how the performance, how the execution speed changes as the volume grows, the volume of the input grows. So that's the whole idea. And in this case, if we check the time complexity, we have one loop, so that's n, right? We have n iterations. If we generalize it, because the thing is, we have now a constant number of iterations here. We're looking for 3 elements, and always for 3 elements, supposedly. So if they ask for find n largest elements, then this would be on time complexity, not just the loop. For now, let's ignore this part within the loop, whatever it is. Just the loop on its own would be on, but they ask for a constant, so technically it would be O1, but actually that's not the answer that they would expect from you, because the thing is, this should be a general one. So actually, let's generalize it a bit. Find n largest, or k largest may be better, because n we can use it for the iteration later. Let's use k largest, and for this we put here k, and here we put 3. There we go. That's how we generalize it, and we just have to rename it to find k largest. And there we go. So now this one has, just the loop itself has a time complexity of on, but underneath we have other things. We have a max function, which also has on time complexity. So already it's going to be n times n time complexity, which is n squared time complexity. And besides, we also have this result insert. And what happens here is that because of how Python, how the arrays have, the values within the arrays have fixed position, when you insert something to the beginning of the array, all of the other elements have to be shifted in front of it. So what happens is that basically, let's say you have an array like this one. If you were to insert anything here to the first element of this, basically they have to shift all the elements one position away. They repeat this process until there is space for this new element. Not to mention about how, but this one is a really interesting question that I will get back to later, because appending to an array is O1 in most cases. So if you put it in the end, usually that's not an issue, because the array can expand a lot easier at the end of it than it can accommodate new items in the beginning of it. It sometimes even expanding can be costly, but typically no. It's all because of how the arrays are implemented by Python. So in most programming languages, you have a fixed size for the array. Well, we call it array, but it's actually a list in Python. And if it has a fixed size, what it means is whenever you want to resize it, you have to repopulate a new array with the appropriate size. But what Python does under the hood is that they try to hold 1.5 times more space than how many elements the array contains initially. So they always increase the size by 1.5. So you don't see it actually, but this array may look like this under the hood. A lot of these are just not allocated, the elements, and that's why you can easily append to the end of it and not to the beginning. And what this means is that they have some kind of variable to show where this array ends, but under the hood, this array goes on for longer in most cases. And once you reach the actual end of the array, they have to repopulate a new array, and then they have to move all the elements. And basically, the complexity of that append process in that case would be on. So to summarize, what it means is that when you append, typically it's going to be O1, but in worst case scenario, it could also be ON. However, for simplicity, we just treat it as ON. Sorry, we treat it as O1, sorry. We treat it as constant time when we append. Now that's not the case for insert, because when you insert to the first position, all the other elements have to be moved forward. So it's always going to be on for the first position. If you were to insert to the very end, it's basically just the same as append. If you insert before the element, right before the last element, even though you only have to move one element away, it would still technically be on, because it's about the principle of how you would have to move all the elements to the right. So it's a little strange, but yeah, that's just how it works. That's why I say that time complexity analysis can not always yield a good estimate of how the performance is going to be. So it can actually, sorry?
But complexity is not usually the case on the interviews. Like they don't give you like large.
That's also a really good point. That's also a really good point. But here they actually ask for the time complexity of the function that had to be written, which is really strange. Yeah. Especially because you have to understand how this is implemented under the hood to give a real-time complexity analysis. Because just by looking at it, you would say, okay, probably n, because we have to do one iteration. We don't have other iterations inside, seemingly, but actually we have. With the max, we have another n iteration. With the insert, we have another n iterations. So it would be same as n squared, 2 times n squared, basically. This would be like 2n squared, yeah, can say, or 2n squared. But what happens is that in time complexity analysis, we don't care about the constants. So this just simplifies to O(n) squared. But O(n) squared is not a good algorithm, of course. It's going to slow down a lot once the volume grows. So we can probably improve it. Actually, O(n) times m, to be more precise, because we're not iterating the same number of times as here. So it's or let me just check. K array, yeah, O(n) times m, n times m, yes. O(n) times m, because the sizes are different. What I mean is that the input has, let's say, a size of n, and this one, the k, let's say it's the size of m. Then this is m, this is n times m. Just we reorder, it would be m times n, but we reorder it because we like to keep it alphabetical to make it more organized. That's the idea. So it's still not good though. It's pretty much the same as O(n) squared. The idea is the same. So how can we improve it? How could we maybe improve it a bit? There's actually a way to improve it even without sorting. We could write our own sorting algorithm, but there is no need to do that. There's an easier way. So first of all, we have to find the maximums, and yeah, we have to find the maximums, and the insertion here takes a little too long because of all the shifting. So we could do something about this, right? So we can make use of the fact that if we keep this one sorted during insertion, then we don't actually have to find the maximum. Yeah, maybe we can do it step by step. Let's see. If we know that this is sorted, and we know that this is sorted, we don't have to find a maximum step by step. But yeah, we could actually, what we could do is we allocate k number of times the elements. So we put these as the elements in a sorted way. And once we have that, every time there is something larger, then we insert it in the appropriate position and remove the first element. Well, we can actually just replace at the appropriate position. That would be the best. So what do we do? Let's think. So, and if we do this, it would be, we can use binary search within the sorted result. And in that case, it would be equivalent with O log times n. Sorry, n times O log times n, because there is an outer loop as well. Log times m, in fact, because it has different length, but yeah. So to do this, we can just initialize it with the first three elements. And from there, whenever we see, so we have to add a condition. So if result length, so if the length of the result is less than k, basically we're going to add all the elements. For adding and keeping the order, we can use something called insert ordered. So import, we import it from collections. I think it was in collections. Insert ordered Python. Let's see. Insert, yeah. Oh, it's within bisect, my bad. From bisect, import, insert. And this one we will insert the element in order. So why is it good? Insert, you have to give the first, you have to give, let me just check the documentation. So first the A is going to be, I think, the array, and X is the value. Yes, X is the value and A is the array. So we add result, and the value is going to be, in this case, array I, but but now we don't need the K anymore. Instead, we're going to use the length of array. We're going to iterate through the elements of the array. In fact, we don't need this at all. We don't need the position anymore. We're just going to use n in array. And basically, we're going to insert n. Let me show you what it does. So basically, import bisect. Actually, let's import from bisect. Let's import the insert. And let's say we have this array that is empty. Array insert 2. We cannot call it on, sorry. We have to do insert array 2. Now array will have 2 as an element. And if we insert something like 1, it's going to be inserted before. And if we insert something like 100, it's going to be inserted after. So it's always keeping the order. It's a really useful thing, right? You don't have to implement it from scratch. So it's keeping the order. And that way the array will always be sorted.
And if they say we cannot use insert?
If they say we have to implement it ourselves. So in that case, you would have to do, okay, def insert binary insert, let's say array, I don't know, let's call it elements. And then what do we do? Length of array divided by 2 is where we're going to start off. Actually, as the 0, it's going to be left, right, 0, and length of array -1. I'm trying to remember. Let's see. Middle is going to be, we're going to calculate y left while in this case, we want the 2 pointers to meet, I guess. Left is less than right. Left than or equal, right, I think. And then left, we have to find the middle. We add left plus right divided by 2. And we have to use integer division. And in this case, we're going to have the middle, okay? If middle is less than element, it would mean that if middle is less than the element, that means the element is more than middle, and it means that middle has to be moved more to the right. So left is going to be equal to middle in this case, middle plus 1 actually. And else right is going to be equal to middle minus 1. And I hope that I implemented this correctly. And then we return, I think we return left probably in this case. Let's see. Let's see if we did a good job. Finally, insert array and 101. This is easy to check. 0, 1, 2, 3, 4. That seems right. That seems just about right. But I think we might need to return right, maybe. Let's see. Because it would be nice to see where exactly is the position where, oh no, this one seems, we need the position before that, I think, in this case. Let me just check. Yeah, in this case, let's see, -1. It's -1. No, we're probably better off with left. So yeah, basically in this case, is the same as from bisect, import bisect left. Basically, we implemented the same, I think, bisect left. And if you try array 100, I think it's going to show you the same. Oh, I think we're off by 1 in that case. Yes, yes, we're off by 1, I think. So let me just change this to right then. Binary insert, and let's see the bisect also. Okay, and let's do confirmation. This is 0. And this one will be, oh, sorry, this one will be -1. I think maybe because of this, if I had to guess. Let's try again. But we agreed on right. Now it looks good. 101 is 3. And was it the same for bisect left? I think yes. 101, 4. Oh, we keep being off by 1, it seems. I think because they have some implementation that if middle -1, left is equal to middle +1, right is equal to middle
Right should
minus.
be equal to middle, no? Without -1.
If we make it equal to middle,
Because if you insert that new object and it's gonna be moving it to the right, the right one is becoming middle. Maybe I'm wrong. I don't know.
No, it actually makes sense to me. I get why you mean that could be the case. Oh wait, this is the bisect. still this. I think maybe because I think it would be easier to just try to see what exactly is happening, to try to understand what we are writing. Let's try that. So 0, 1, 2, 3, 4, let's say, just to keep it simple. Or let's make it 2, 3, 4, 5, 6. So let's say we are inserting, okay, let's make left pointer and also right pointer. And let's try to see. So the whole length is equal to 5, right? So let's note the, I mean, we can note that this is 5. And that also means that we start 0 from here. Length minus 1 is going to be at position 4. This is at position 0. And we have to find the middle. Oh, and then we have to find, of course, also the middle. Let's make it like this. So middle in this case is pretty obvious. Let's say that we want to find where to insert the number 7. So if we want to insert number 7, we can put this here.
3 will become middle.
Oh, no. I mean, this will, 5 will become middle. Because we're going the other way around. But the thing is, yeah, the way we implemented, okay, is that we went over to 5. And then this is 6, 5, 6 in between. If we add these two together, it would be 0, 1, 2, 3, 4, 7, 3. So it's gonna be at position 3 here until now. And then in the end, we can still calculate the next position. And the next position would be, well, actually from here, first we're gonna increment left by this much. So it's gonna end up here, right? So this one is okay. This one would be okay. But what if we want something smaller? So this side is okay. Let's try also the smaller one. Let's say we are trying to insert something like 0. If we repeat the same process here, oh, my bad, other way around. So if we repeat it, okay, we go in the middle with this one. And, well, actually here with this one. And this one will end up where? Let's see. Well, if right is equal to 1, left is 0, then actually right is, sorry, the middle is also going to be here. So we could just actually return the middle, it seems to me, as long as it's assigned. Only thing is we didn't assign anything initially, so maybe we can, the middle is equal to -1 just to initialize it, and we don't get the warning, but it's not that important as long as we give something that has a length of 0. Yeah, actually, let's make it 0 if we give 0 length, because otherwise it's going to give us warnings. So let's try to see. Array 0, 101. Middle is not, oh yeah, because in the previous case, the middle is not going to end up there. Yeah, in the previous case, the middle was not there, but on the other side, I think. Okay, so maybe we were better off with the left one. Yeah, it can be tricky. Actually, if you once remember it, it's probably easy. Let's see, binary. Let me see my mistake. Insert. So we have mid, start, and divided by 2. They do floating point division, which is a bit strange. Okay, but this is binary search. But yeah, basically, we want something similar. Not exactly the same though, because we're not looking for an exact item. We're just looking for where the new item should be placed. J in range. Okay, -1. Let's see. Yeah, but most of these are with binary search. Binary insertion sort. So for I in range 1 to length of array. Yeah, it seems like it needs binary search anyway, but array middle less than key. What is key? Okay, that is the key. So wherever it ends up, okay. And then it actually returns the middle, in all cases, it seems. So maybe because we calculate the middle in the beginning, and we should calculate it after somehow. Let's see, middle is calculated here after. And the condition is what? Let's see. Array middle is less than key. Array middle is, if it's exactly the key, then it will terminate. But we're not looking for an exact item. That's why it's a little confusing. Enter the array number. So it does look like it's inserting it in a sorted way. Array, yeah, and then it iterates through the array starting from 1, which is strange. Why it skips the first one? Let's see. 1 to length of array. Temporary array. Temp is gonna be array I. And binary search array. Okay, there are some other concepts here. 0 I. Start is gonna be 0, and is gonna be I plus 1. No, it's we'll have to better understand this part. Anyway, let's just stick with the insort for now. But basically, you'd have to you'd have to implement the binary insert with the appropriate position. Also, let me just try. If I want it to work same way as bisect left, what's missing? Let's see. Comparison, if middle is array middle is less than, comment is you should compare the value at the middle index in the array to the element. There's no if middle. As far as I see, there's no if middle. So yeah. Ah, okay, here. If middle is this. Oh, okay. You're right. I wrote if middle instead of if array middle. That's a good point. I thought that the issue was like off by 1, but it seems like it's not even that. However, it still does not yield the same that I was expecting. And if I try this one, it says 4, maybe with right. Right is equal to middle. The rest of them looks the same, basically. Right. And length of array. Yes. We have to start from length of array y. Yeah, because of the calculations. Right. So there was off by 1 also, but okay. Now it makes sense. Okay, my bad. So basically we need to find the length of the array. We don't take -1 because for the calculations to get the right position, we need the actual length. And actually when I was showing you this, I was also counting the length, if you remember. So I should have realized that we need the length and not -1 here. And then we get the element in the middle. Rest is okay. And why not middle -1 is because that way middle -1 would I guess middle -1 would be fine here. I could be wrong though. Because if I remember correctly, we implemented previously that way. Yeah, it actually looks good. I think the same happens. It's just gonna be a little bit slower if you don't add -1, from what I see. Yeah, we can actually write tests for that. This could be an interesting homework later, maybe, to compare the two and see with random values and arrays. Anyway, for now, let's just try to see how we can make use of this, because I left off over here. So we want to insert to the array using this binary insertion. So to do this, we have to find the position where we have to insert. Actually, we want to find the position that we want to replace. We want to replace that position. So in this case, we can actually initialize. Actually, we cannot initialize this part just yet. Okay, let's say slicing is not allowed. It would be more elegant if it was, but anyway, let's think that it's not allowed. Let's assume that. Then we can use this. And here we can use our binary insert on the array. And we're going to add the n. And else, what do we do? Basically, we want to find if result 0 is less than n. It would mean if n is greater than or equal to, or yeah, let's make it that way. It makes more sense. If n is greater than this. So if n is greater than the smallest, largest element, then we have to find where to insert it in place of what. And to find that, oh wait, yes, yes. So in that case, result binary insert array n, but this just gives you the position where to insert it. So it's important to note that we also have to use result that insert. This is going to be the position, and this is going to be the value. For now, let's just see this part. So if you do this, you will see that result insert binary insert array n. Instead of array, we need to use result, actually, result n. And you see, seems wrong. Let me just see why. Because now we check binary insert result n, and this n should return the place where we have to insert it. In place of what? I think maybe we need n plus 1 for, oh, sorry, for the insertion. No. Okay, let me just do it with the insert. Result and the n. So if you do it with this way, it's gonna keep the order. I don't know what's up with the other one that we wrote. We'll have to test it. So it keeps the order, and that is the idea, that whenever you have a larger number, you have to insert it and drop the first one. But I'm thinking that it's still not the best approach. But yeah, anyway, this is what I found, that if you have this, you want to always drop here, remove the first element, result that pop, you pop the first element, and the result that or insert result, and then you add the new element, and then you have the largest ones. So that would be the solution. But I think I remember it being more efficient. So actually, I want to see. I feel like it was more efficient when I checked it, because now when I check this one, what is the issue? It's the same issue. For the insertion here, you cannot. I was thinking that you would just replace the appropriate element, but now I see that you would have to pop one of the elements and insert a new one. So it does the same. That's why I'm thinking if it was maybe more efficient. Well, this is for the merge. Lord. But no, actually, you still need to pop it and then insert in order. But yeah, so for this one, honestly, the easiest way would be still by far if you could just if you could simply sort it, get the last 3 elements. That's by far the easiest solution. And yeah, this one is, you see, here in this case, I checked if yeah, this one is a little nicer, because I checked if the length of the largest is less than k. Basically, in that case, always we're going to be inserting, and if length of largest is greater than or equal to k, we're gonna pop the first element. But this should only be true if because this will be false in that case. It would also mean that okay, it's a matter of preference which one looks better. Actually, this is probably easier to read a bit. So basically, we use binary insertion, but still we would need to pop from the beginning. So honestly, not a fan of either one of these solutions. Without sorting, I don't think there's a really nice solution for this. There's another one we can do. I'm going to keep this one. I'm going to look into this later. But basically, you could also use something like from collections, import deque. So the deque, it has it's a linked list basically. So what it means is you can imagine that the elements inside are connected, are pointing to each other. So you have numbers like, let's say 17, 18, 19, 25, something like this. And all of them have a pointer to the next element. And you can imagine why this one has an advantage. Basically, if you insert something new, if you insert a new element, you don't have to shift the other elements. All you have to do is change the pointer of this element and of this element to the new element, and the new element will point to the element that this one was originally pointing to. So it could point to, let's say, 20. And then all you have to do is just add one more of these pointers to the next element. So for keeping the order, this is really the best best data structure you can use. And for that, we can also try that. Yes, let's do this. So DQ, or let's say DQ from the collections. If the length is not that, then we can use DQ dot insert Q and K. I hope I got the order. So N. I hope I get the order correctly. Let's see. Insert X in list A. Okay, but is it the same order? A is the first one and X is the second. Okay, looks good. For now, maybe let's just try to see if this one works. Oh yeah, that one has no length. If we wanna keep that one ordered, basically. Oh yeah, that's the downside though, in case of DQ, right? It makes sense. Because if we want to keep this structure though, it would also mean that we have to iterate through during insertion until we reach the point where we want to insert to. I remember in actually implementing in DQ also. Basically, you have to iterate through up until you find where to insert it. And once you have that, you can add it. And yeah, what else? You could actually make the same for all. Maybe I use DQ in the second one, but anyway, the best one I think is still this. Yeah, this is still the best solution, I think. Actually, the funny thing is if you ask ChatGPT to generate a solution for this, let's say I open a new chat, solve this in Python. It will show at least last time I tried, it showed a pretty ugly solution. Okay, this one, it uses sort, of course. Update largest, 3 largest. Yeah, so what it does is that it keeps rotating between those 3, which is not something you can do once you have more than 3. So, and that's why the exercise is a bit strange, because they asked precisely for 3. They didn't mention that this can change. You should probably think about that on your own anyway. But basically, if you try to do a solution like this, it's impossible to do this with 90 different items, because for 3, okay, you have to only rotate it in 3 different ways, but for 90 it would be a lot more. So this solution is not good, and you'd have to ask like, okay, just a moment, but what if you have, what if you need to find k largest ones? So in that case, it wouldn't actually suggest that solution, of course, because it's impossible to do that. And instead, it would suggest something like update k largest num. Basically, it checks if it iterates through all the elements and checks if num is larger than any of the already existing ones. It basically finds the position also that way, and it updates. Yeah, shift and update, so it's gonna shift it away within the array. Yeah, it's neither of them are too nice. Okay, just an example. I think this was the worst. This was the worst exercise of the two. The other one was a little better at least. Let's say that one too. So in this case, we had to merge two lists, but the trick is we had to merge in place of A. So suppose you have a list like this, and you have to merge A in place. So what this means is that, let me give you an example. I'm gonna go close these two. So you see, they actually gave you the number of unallocated slots in the array that have to be populated. And that is because you would have to shift around these numbers. And in other languages, you don't have things like in Python. The thing I mentioned that they allocate more space for you, maybe we still have it here. They allocate more space for you in Python, so you can append to the array. But in many other languages, the arrays have a fixed length and you cannot change it. And that's why they added this. Actually, during the interview, the guy even removed it. It went like this, which if you do this, it's gonna be a bit of a nightmare to work with, because they asked us to merge the two lists in place of A. So what it means is it's gonna be the result is gonna be A with the items merged from this one. And actually, this is where you can use the insort again. You could also use that.
There is
That could
also
be
like merge function, no? Or
merge function. There's a map one. There's a map, but that's different. But merge, I didn't know about this, but heap queue merge. There's a heap queue merge, but I don't know if this is for sorted inputs into a single sorted output. But the issue is this one is going to generate a separate list, and we have to merge them in place. So we cannot use this because this would result in a new list, which breaks their own constraints that they set, which is partly why they set it, because they want us to implement it. So let's try that. So if you have this one, this is really bad because we want to get back the original with the none or zero or anything in there to have something representing the unallocated slots. So what you could do instead, in case they do this during the interview, which is a bit of an asshole move on their part because it's just gonna make your job harder. Basically, you want to add b times many zeros. Maybe you don't know exactly how much it's gonna be, so you could just say length of b times zeros. And if you have this one now, and I hope I did it correctly, let's see. No, we have to put actually, probably easiest way would be simply, let's put it back and go like 4 in range length of b. And then we just add the zeros that many times. So a dot append, and 0. And now if you have A, let me print A, it's going to have the zeros or none or anything you want. We can add none as well to make it even more obvious that those are the unallocated spaces. I guess, yeah, it looks good now. And also, maybe we could also do this. I'm not sure. Probably we could do 0 for underscore in range length of B. Let's say we put this down, so we already know how long B is going to be. And then we open it with the asterisk. So we unpack those. That would be another option. So this is another way we can do this. And maybe another would be 0 times 8, 0 times length of B. But I think this one doesn't unpack it. Yeah. So probably you could still unpack it if you put this in parentheses. Yeah. So you can do it multiple ways. Look, I'm going to keep it this way. It doesn't really matter. And once you have that, you want to merge the two together. So how do you do this? Now you have to find the length of A, B, and the merged list. So you're gonna need 3 pointers. You need a pointer for the merged one. That's gonna be now the length of A minus 1. You're gonna need a pointer for A itself, which is gonna be pointer A. It's gonna be length of A minus length of B minus 1. Why? Because we're gonna take out these zeros basically to get back the original length. And this is where we're gonna start iterating through A. We're iterating from the back to the front, and you'll see why once we start doing it. PTB is equal to length of B minus 1. And now the idea is actually quite simple. We just want to iterate through these two. Let me just show you here. Okay. So we just want to iterate through these two from the back and merge them together. And I'm going to add the empty slots here. And too bad we cannot just move it individually, because that will be really handy. That would be extremely important in this case. So I'm just gonna draw it up quickly. Let's do this 1, 2, 4, 5, 8, empty, empty, empty. And then in the other one we have, I'm gonna move it up. I hope it's still readable. 3, 3, 4. And basically, let's also put the pointers there. So this is going to be our pointer to B, our pointer to A. And for the merge pointer, let's also add one. So this is going to be our merge pointer on this. Okay, here we go. So what do? Basically, we have to compare A and B. And the condition is going to be that until we reach the end of B, we're going to go on. So we compare A with B. So this is A. Okay, this is A. Let me just maybe put it here to make it obvious. So this is A. This is A, and this is B. And we have to go from the back to the front. And we compare the two, and whichever is going to be larger goes here first. Okay, so first we compare B and A. So 8 is larger than 4, so we're going to put that in the end. And we go on to the next element. So we're going to decrement the pointer of A to go on to the next element. 5 is larger than 4, so we still repeat it. And we go on to the next element. 4 is not larger than 4, so we can actually put from B as well. Then we decrement B. 4 is larger than 3 though, so now we once again repeat it with A. 3 is larger than 2. We go on to the next one. 3 is larger than 2. We go on to the next one, and now we reach the end of the end of array B, and we can stop here and we're done with the merging process and it's done. That's all we have to do actually. It's as simple as that. So now we just have to implement this. And I'm sorry, I wasn't doing this in the meantime, but basically with every step, you're also taking this to know the position within where we are within the merged array, because it's not obvious. So what it would look like again, just to repeat, this goes here, and this one goes back. Every time it's going to go back by one. So this goes here, goes to the next one, this one decreases. Then this one decrements, and this one also always decrements. Then this one decrements, and always this one decrements. This one, this one, this one, already at the end, like this. And yeah, whenever we reach the end of B, that's where we're going to terminate it. So we say while pointer B is greater than 0. And point greater than 0, yes, because greater than or equal to, actually, because we're going to reach the last element also. And we do comparison between the two. If A pointer A is less than, let's say, greater than B pointer B, or let's start from B maybe, because the condition is dependent on B, so that's why I want to start from B. If B pointer B is greater than A pointer B, pointer A, sorry, in that case, we want to add to the merge pointer, this one, A merged pointer merged, is going to be equal to the value within B, so B pointer B, and we're going to decrement B pointer B. Pointer B, sorry, pointer B minus equals 1. And then else, we're going to decrement pointer A. And also in that case, we want to put pointer A in place of A pointer merged. A pointer A. And in all cases, we're going to decrement the merged one. And let's see. There we go. As simple as that. It's not too difficult to implement, as opposed to, I think the previous one is more complicated. This one is a lot easier to illustrate too. And yeah, we can also try it with some more. We can try to see what happens if it's a lot shorter. Is it still going to work? Yes, still working nicely. So that's how we can merge in place. And maybe we can also just debug to see a little nicer what is happening here. When you have this, 2 greater than 0. Okay, so B pointer B. Okay, of course, you have B. These are the elements of B. So pointer B is going to start from 2. That's the last position within this array. We check if 4 is greater than 8. That's going to be false. So it's going to go here. And it's going to add this element, A, 8, to the end of it. As you can see, it keeps this one, by the way, but it doesn't matter. It's going to be overwritten by the appropriate value once we get there. So it's not an issue. You will see it later. We could write it also to 0 if you want to. For debugging purposes, it would be nice to see, but doesn't matter. So we go on because pointer B is still greater than 0, greater than or equal to 0. Once again, we check. Is 4 greater than 5? No, not true. So once again, we're going to add 5 over here. And 5 stays here too, but again, those two will be overwritten. Okay, we go on. Still the same. And then we check, is 4 greater than 4? It's still false. So actually, we're still going to put 4 also over here. Going on to the next one. And now we will have, is 4 greater than 3? It's going to be true, or 2. Okay. Is 4 greater than 2? It's going to be true in this case. And now it's going to replace 8 over here with 4. You see? And goes on to check the rest of these. And is 3 greater than 2? Yes, still, it's going to be true. So it's going to replace this one with 3. Now, in this case, it's not going to be true anymore because it's still going to be 3, right? We still have one more 3 left. But in this case, oh, we were comparing it with true 2. My bad, yeah. So it's still going to be true. It's going to replace the last one with 3 here. That's it. And now you will see that PTB is equal to -1 actually, because this was the last element within the B array. And because it's less than 0, now we can exit from the loop and just print A. And that's it. That's how we can replace it, how we can merge it in place of A. Is it clear?
Yeah.
All right. I think, yeah, the previous one I think is a lot harder because they set the constraint and that and then you have to think about how to work with those constraints a lot stricter. Yeah. Okay. Yeah. Yeah, this one is still not really a nice solution because of the pop. Still gonna be n squared or n times m at least. Okay, let's I think that's enough from these exercises. And actually there's one more I mentioned, but I think I'm not gonna cover it now. Maybe I will just cover it next week because it's unrelated anyway. It's a batch exercise. And I was thinking about covering a bit more instead about, I'm going to cover a little bit about logging. So I'm going to just go over to the classes and I'm going to create a folder for this class. So let's do session 2024, 10, 19. And let's try a little bit of logging. So of course, there are numerous purposes we log for messages to ensure proper monitoring within the system. And we can see a lot of insights, like why exactly an exception happened. Because of course, when we are in debug mode, it's very easy to see those kind of problems. But when you run it in production, it's not going to display all the issues by default. So we can make use of logging in that case. So we're going to be using this library called logging in Python. And the way it works is there's a root logger attached to this library. So out of box, you already have something that you can log with. So you can do logging dot, let's say info. There are different logging levels. Info is a pretty generic one. You say test. You'll notice something. It's not going to display anything. Why? Because you first have to configure your logging. So to do that, you have to do logging basic config. And here you can set what level should be logged. And what do I mean by level anyway? If you go down here in the documentation, you will see that there are different logging levels, such as info, error, and critical. I think here it's a lot easier to see. So there are these levels. We have not set, debug, info, warning, error, and critical. And they all are used for different messages. So debug is only for developers. In production, you're not going to see these logs. And typically, you will not see this. unless they're actively looking for something. Info is for user interactions typically. Yeah, when things work as expected. Warning is when something is not quite good, you know. For example, they mentioned this place is low. That's a good example. Or you're running a little bit low on RAM. Not something that is immediately an issue, but could be in the future. Or maybe another good example could be the response time. If the response time is slower than what you were expecting, then you could add a warning like response time was longer than expected. That's also a common one. And then you have error, and this is to, of course, show errors, something that was not expected or shouldn't have happened. Also, if the user another example could be maybe, although this can be warning an error too. If the user enters some incorrect data that we were not supposed to, you can log it as an error or a warning, depending on what you want to make out of it. And then you have critical, basically something that could prevent the program from running further. Disk space is low, for example, they mentioned it in warning, but if the disk space is so low that you only have like, I don't know, 1 GB left on a 1 terabyte drive, then you could also log it as critical at that point because it could actually prevent you from running the application in the near future. So that's definitely something to investigate quickly. And besides these, you can also define your own levels. And you see that they use these numeric values with a difference of 10. So probably if you want to define your own level, you would want to add 60 next, unless you have some specific reason to add a different number. And the way it works is if we set the level here, whatever level you set, only anything coming after that will be logged. So if you set it to error, it would mean that only errors and critical messages would be logged. So the warning, info, debug, these would not be logged. And not set, it's not something we use actively. It just means that it's literally not specified yet.
It's info, warning, and error. I mean, that's what I see in the production.
Yes, those are the most common ones, yes. And debug, it's only really for debug, and critical, you're not supposed to encounter it a lot. Yes, that's true. Mostly just the info, warning, area. Those are by far the most common one. It says when set on a logger indicates that the ancestor loggers are to be consulted to determine the effective level. Yeah, basically what it means, we'll see that there's a hierarchy between the loggers, and if you do not set the logging level, yeah, in that case, probably the root logger would take care of whether to show that message or not. Anyway, let's see a simple example. So now we try the info and it doesn't show it. What we could do is we change the level to info. If we change the level in the configuration to info, it's gonna show now this message. You see, it shows the level, it also shows the logging module. But the thing is, it's still not going to show something below info. So what is it gonna show now that I set it to info? What do you think?
Everything after info?
Yeah, exactly. So warning, error, critical, they would all be shown, including info as well. But debug would not be shown. If we try debug now, it will disappear. It's not going to appear yet. So if we want to also show the debug messages, we would have to change this to debug. And then it will also be shown. So that's about the levels that I wanted to mention. We can also change the format. It's a really useful thing. We have some really nice formatting options here. We check these. you'll see that now the default format is something like this. You see, we have the level, we have the module name and the message. If we wanted to replicate it, we would have to add the module. Oh, damn it. Module. This will be in the middle, actually. So let me put 2 columns around it. And it may seem a little confusing at first, but these S and D and all these just represent the type. So it's going to be a string. This one is floating point. This one is a decimal. That's why we have that there. And first thing we see is the level, more precisely the level name, because as you could see from the previous page, there's also the level number, but typically not something that we want to log. And also the message, of course, we want to add the message as well. So now if we do this, it's going to show exactly the same as before. I just wanted to show you to understand how this works. But now from here, we can also replace it. Let's say we want to use dashes instead of the columns, then we can use dashes. And oh, this is the module. Sorry, I wanted to add the logger's name. This was the original. It said root, yeah, the logger's name, because this is actually the root logging, as I mentioned, the root logger when we do not specify another logger, and we'll see how to create a logger in a moment. I just wanted to mention a bit more about the formatting option, like what else can we add? Another really useful one that we typically want to see is the time in the beginning. So we can add the time this way. However, I'm not a fan of this format. I think I'm probably not alone with this one. I mean, it's kind of regional as well. I want to show you why. Because if you notice, they use comma here instead of dot. I think in the US, maybe it would use dot in this case. I'm not sure. So if we want to standardize it a bit, we can use some date formatting. For date itself, we have a date format attribute within the constructor. And we can completely customize it using these date codes that I showed you previously. We can just Google Python date formatting codes or something to get an idea of those. I just like this site because it breaks it down really nicely. Basically, it uses the same as in C programming language, the string from time format, if you Google it. Yeah, it actually showed you also this one. This is also a nice one. Oh yeah, this is really nice also, specifically for Python. So we want to use, if we want to use something more standard, we can use this ISO 8601. You see, I'm sure you must have seen it a million times. This format, we can use this one. So I'm just going to copy this and put it as the date format. And there we go. It looks a lot more like a real log that you see in different applications. And yeah, for the module name, maybe let's keep it a little more compact. Back to the columns. Okay, here we go. Yeah, it's completely customizable. You can also add some other things. You see there's also path name, process ID, stack info. Okay, and yeah. Most typically you will see the ones that I showed. And there's also execution info. But for this one, we don't actually have to include it ourselves. They also mention here. Because or exception info, sorry, exception info, because when we log an exception, there's two ways we can, actually, the standard way we should log an exception is using the exception method, this one. And this one does the same as if we logged an error. Let's try it actually. So if you want to log an exception, let's say we want to divide by 0. Try 1 divided by 0, except, and division by 0, 0 division error. We can log it, logging that log, let's say error as ZDE. I'm just going to store it in a variable. I'm just going to call it division by 0. Yes. In fact, message, and we have this execution, sorry, we have this exception info as keyword argument, and we can set it to true. And you will see in that case, it shows where this error happened. So we can actually write here, this user once again divided by 0. You can add some custom message. It will appear here. But besides that, you will also have the trace. As you can see, it will show you where the exception happened and all that. But you don't have to use this one. There's a really nice shorthand that does exactly the same. Instead of error, you use the exception. And it's going to show you all the information about the exception. So this one should be used within the try except block. More specifically in the except block. So if you call this outside, of course, it's not going to show any information. Let's say. It will not show information. You see non-type none is showing this because there is no exception happening at that point. We can actually even get rid of this one. There is no exception happening at that point, so it's not going to show you the trace because there's nothing to show the trace through. So you should only call this within the except block. What you can use if you have some error, like user error, let's say wrong input, you can add this. For example, a good example is enter a number or enter a positive number, let's say. And they enter it. Then we can check number is digit. Let's add it in an if not number is digit. So if it's not actually a positive number, this user entered text when number was expected, something like this. Else we're just going to convert it to, let's say we convert it to number. And then we can say number plus 5 is equal to number plus 5, just to have something. So now if the user enters something like 10, it's going to work as expected. Very nice. However, if they enter something like text, it will say user entered text when number was expected. You can log the error this way. So yeah, that's some examples of the levels, but there are some more customizations we can do. We also have, let's get into the loggers that we can create. So typically you shouldn't be using this logging modules, debug info, and all of these methods. Instead, you should create your own logger. This one will be what the logger uses also as settings, but you can override it within the logger. So to give an example, I'm actually gonna uncomment. I'm gonna comment out these for now. This is test from root. I think it's okay not to specify because the thing is we'll see it and it will be better seen there. So let's add the logger. We just do logging.get logger. And here you have to enter a name. By convention, we just type double underscore name double underscore, and it's going to use the module's name. So in this case, main.py as the name. And we can compare the two. Let's say instead of this, I'm going to be using loggers debug and loggers info. So you see, it looks almost exactly the same, but now you have double underscore main double underscore in as the name of the logger. Whereas for the root logger, you have the root. And you can also override things here. For example, let's say you want to change you want to set a different level. Maybe you just want to show anything from info. You can set logging.info. You will see that in that case, even though the root logger still logs the messages here, for this one, it does not log it. Only those that are logged only after info. So if I put something like error message, is still going to appear, but the debug messages will not appear. So that's how you can separate different loggers. So this is like global setting, but you can customize the logger's own settings. I think there are other things also we can customize. For example, yeah. I'm trying to see if there's a good example. Probably, I believe it's also possible to set custom formatters. Maybe let's try to see if there is an option here. So in the get logger, it only takes name. Yeah. All right. So for the formatter, it would be tricky, I think. Formatter. Yeah, it's not exposed, it seems. Anyway, so most specific, most typically, we'll just set the level for different loggers. But the most important part is just to be able to separate them. So in this case, it's easy to distinguish because you'll see the module name in the logs, and you will see where it's coming from. The logger's name, not the module name. The logger's name. So you can enter actually anything like my custom logger, and then that one will appear there. But I think it's okay to keep it as name. And what else? Let's see. We also have this propagate, and this one is whether this one is also propagated to root. But I think it doesn't matter here because, yeah, I think it doesn't matter here though, because one stream only processes the log only once from what I see. So let's try to see the handlers instead. So now you saw that we can log the messages to the console, but you may be saying that, all right, I mean, I can do this even with a print statement. You don't get the color, but it doesn't matter. That's not really the point here. What if I want to log to a file? Well, you can actually do that. You just have to enter file name, and you enter, let's say, main.log, because it's about the main file. You'll see it appears here. And by default, it's going to append to the file. As you can see, every time I run it, it's just appending to the file. You can override that also. There's also file mode. If you want to replace every time, you can use the W. It's going to recreate it every time. So it's going to stay the same. Or file mode A, this is the default one. So if you run it like this, it's going to append. You can actually get rid of it because this is the default. One thing you may have noticed though, that now the messages are gone from the console. So if you want to add both of those, you got to get a little bit tricky. You have to import system, and you have to manually specify both of the loggers. You have to specify the stream handler, logging that stream handler. You have to create one for that. And you have to add, sorry, you have to add also system that standard. You can use standard error. That's actually what it uses by default. The standard error stream. And in this case, also, it's quite unhappy about the fact that you're using the stream or file name with the handlers. You cannot use that, so you have to get rid of the file name in this case. And instead, when you create the file handler logging, file handler, then you have to specify the name of it, like main.log. And here you can also, I'm sure you can also set the file mode and all that. You can see you have the mode, encoding, delays, errors. You have all those options. It's just now you have to specify it here. So it doesn't work together with the if you have the handlers specified, you cannot use the file, what is it called? File, let me just file name here. You cannot add the file name attribute here. You have to instead add it manually like this. That's just a rule, but it's easy to get used to. And that's it. There you go. It's done. And I guess needless to say, but let me also mention that suppose that we don't add these. Okay, now the log is like this. We have quite some. I'm going to delete it, so it's empty. So now by default, it uses just the standard error stream. It doesn't use the file stream. We can also just add the file stream and also the error stream to this one. We could do something like this for H in handlers, and we add all the handlers to this custom logger. So not the logging module, but our own logger, and add handler H. And what this one does is that basically, you see that it changes a bit, by the way. It doesn't inherit, somehow in this case, it doesn't inherit the formatting options, which is honestly a bit strange to me. Yeah, anyway. Yeah, somehow the formatting options in this case is not inherited. Maybe because of where we create the file. Most likely, yes. But most likely because we add the file handler here and not here. And we would have to add the formatting option separately somehow. It's a little strange. Maybe we can also do this. Let's try. I'm going to get rid of this because now we only have one handler. Let's call it handler. So you see the formatting option was, okay. Yeah, but in the log, you see, we don't have any formatting applied here. I think probably we'd have to manually add the formatter, which would be the same as logging that formatter. Basic format. I think this one, most likely this one. Yeah. Oh, no, this is just the format itself, but we can use this as a template, and we say logging formatter, and then logging basic format. And then here we go. Now we also have the same format. I can get rid of the previous ones. So yeah, you see we have the same format in this case. Oh no, this is actually the initial one. This is where we started off. Now we already have our own one. My bad. Honestly, I don't know how to get that format. We'd have to, worst case scenario, of course, you can also just copy this as is, or store it separately and reuse it. And then it follows the same format. If this is if we want to add the handler, the file handler, or only for this logger, but not for the root level logging. Yeah, basically. And you can see that to the root level, it always propagates it because it still shows the message here, even though we said that. Oh, my bad. This one is from here. Example 2, example 1. Let's make it separate so it's a little more obvious. But yeah, actually, this one, the test was shown. Yeah, because we had it set to, where did we set the level? We set the level somewhere. Yeah, here, debug. So example 2 is shown. Example 1 is not shown for some reason. Even though we set it to debug, but we already overwrote it here with info. So if you wanted to see both, either you get rid of this or you set it to debug. There we go. So thing is, this one is from our own logger. This one is from the root logger. And in both cases, it reaches the root logger. So you see that we added this handler, but this is a file handler. So by default, it would not print. If it wasn't for this configuration, if it wasn't for the fact that there is a handler already at the root level that handles the error stream to print this one would not be printed, but now it's printed because of that. And besides that, it's also printed to the file, because we added this file handler, our own file handler to main.log, and it puts it like this. We can also add different format for the file. That could also be a useful use case. Maybe we don't need the the name because we know that it's gonna be the same module. Just get rid of it, and then it will just show this one. But wait, yeah, here, these. You see previously we had the module name, so the logger name. Now we get rid of that one.
But on the
So
bottom, it still says main, right?
in what?
In the terminal, it still.
Yeah. Yes, it stays the same because yeah, because it now it gets a bit tricky because we use this formatter, but the only handler we have at this level is the file handler. And this one is actually propagated to the root handler, to the root logging, and it has a standard out handler, standard error, and that's the one printing it. And that's why we see the module name, even though we set a different format. Because it's the format of the handler, actually. The format is, seems like the format is completely tied to the handler. That's why. So if we wanted to change the format for both, we would have to either change the format here or or maybe we can also do logging that get handlers. Maybe if we have an option like that, handlers. Yeah, we have the handlers here. We only have one, actually. We can print it. Yeah, it's actually nice that it's red because we can distinguish the print from the login. So you see, we have the standard error handler here in an array. If we were to change the formatting, we could do that. That formatter is equal to, and let's say we change it to the same one, or even something like changed, and then it says, you'll see what happened here. It prints it with the normal format here. It prints it with changed here, but to the file, you're not gonna see the change. You're not gonna see, you're not gonna see this changed. You're only gonna see this one. That's really nice. You can customize it completely based on the use case. Yes. I think let's do one more thing. I was going to also implement the handler, custom handler to CloudWatch. That would be nice, but I think it will take a little longer. So I was thinking we could maybe just implement a custom filter to filter out some of the logs that contain certain keywords. Okay, so for that we can use, should we clean it up? Okay, I think I'm gonna keep it as is. I'm gonna just create a new file. Custom filter, let's call it like this. And import logging again. Plus custom filter, let's say. And this one we will implement the filter class. I mean, we will inherit from the filter class, and we will have a few options like let me pick from the documentation. Logging filter. Oh, here we have the filter object. So we have actually just a filter method that we have to implement. And it's gonna filter the records. We have to import this. It's gonna filter the records based on something. We can actually set the keyword here, for example, in the constructor. We can do I think we don't have by default, but let me just check. We only have the name by default. Okay, let's also give a name to it. Name, and we add the keyword. Super. I think the super takes the name. Let me just take so it calls the parent constructor. I believe this one takes the name, but let's make sure. Yeah, it takes a name, as you can see. By default, it sets it to empty string, but okay, let's set that one. So let's set the name. Sorry, in the init, I guess. Yes. And in here, we're going to set self that keyword is equal to keyword. And filtering is going to be quite simple, I think. We just check the message. And we can check if keyword dot lower self that keyword dot lower in record dot message dot lower, let's say, and just return it. We don't even have to check with an if statement. We don't need it. We just return it. We check if this keyword can be found in the record, and it's going to filter out Yeah, it's actually filtering out. So it's not the things you want to keep, it's the things you want to remove. So let's try. Let's do this. Logging that basic config. We can add what options did we have anyway? Yeah, let's set the level maybe. Logging that. Well, I'm gonna set it to debug. I want to see everything. And then I will just get a logger, logging that get logger with name. And then I'm going to set the filter or add filter actually. I'm going to create a new custom filter. This is the one that we just declared. And this one takes a name. Name is going to be my custom filter. Doesn't really matter what we give as a name. And the keyword, let's say example, because we already have, or let's say, let's do something more realistic. Let's think. Let's say things like added, logger that okay, so logger that info added something, logger that info, only this should appear. Log record object has no attribute message. Yes, I think we have to do get message, I guess. Yes, probably get message. Here we go. As you can see, it shows edit something. It doesn't. My bad. Okay, I remembered wrong then. My bad. So it filters and anything that doesn't match the condition will be filtered out. So if this one is not in, then it will return true, which would mean in this case to keep it. My bad. So basically, only this should appear. Yeah. So it's not filtering out. My bad. It's filtering what should be left. Okay. So this is just one use case, but let's say we want to customize it a little bit. We can also add the level along with the keyword, and maybe we could also add multiple keywords to this and dynamically change it also. There are so many options like def condition. Let's do conditions. And here I was thinking that maybe we could check a keyword and level, let's say. Or we can make it a dictionary, but I don't want to bother with that. It would be a lot easier to just use tuple. So here I can do something like what keywords to filter at what level, basically. And we can, instead of initializing at the constructor, we can do it separately maybe also. Or although, you know what, I think it's better in this case because we always have the same levels. It would be probably better to create a dictionary. Basically like this. In fact, I would say let's make a default dictionary. Make it even simpler. From collections, import default dict. And yeah, let's make it string. Yeah, let's do none actually. I think it's possible to do this. And then we check if no. Let's do a list, empty list basically. And then it's going to initialize it with an empty list. And what we do is we iterate through that list. So for f as in filter in conditions, self-that conditions, and we check the keyword. Yeah, we check the level actually first. Record.get level name. I think it should be working. I hope the level name works because I remember we had an issue with the message. Let me just check the level name first. Yeah, let's always return true. Just to keep it simpler. Yeah, okay, the level name works. I don't know why we had an issue with the message when I tried this one. But level name works. So yeah, record level name. And basically, if any of them matches, then we're going to return false. Otherwise, we return true. So if self that, in this case, f.lower, or let's do keyword maybe. Not in. Now we have to check if it's in the message. We return false in that case. There we go. And let's see if it works. And let me show you an example what I meant. You can add a method also. Add condition to make it more readable. So we say level and keyword. And it's just going to say conditions level is equal to keyword, except that we also have to add self in the beginning. There we go. So my custom filter, beautiful. Let's store it. Custom filter. And now we want to filter, let's say, info messages that have this in them. Logger.info. Or yeah, let's do it with something, let's say. Custom filter that add condition. We say info. And this one, something. And now let's see. Added something. It should filter it out. I don't know why it didn't filter it. Let's see. I think I forgot to add the custom filter to the logger. So let's do that. Logger, add filtering, custom filter. Let's do this. It filtered out everything. Let's see why. So return false in this case. Return true in other cases. Yeah, so some condition is not right. If the keyword lower in record, get message lower, in that case, return false. Added something. Why would something appear in other ones? Let's debug it quickly, just to see. Okay, so we have keyword. In this case, keyword is going to be S. Okay, I see the issue now. So basically, it breaks it down to a list. This keyword is broken down to a list, but this is not what I wanted. And now I see what mistake I made. So basically, we have to append to the already existing. Okay, here we go. Because now it was appending the string character by character. So basically, it was adding the characters instead of the string. Here we go. So here we add it. And why is this useful? And here comes the twist. Let me just do it quickly. So basically, if we have a logger.error with added something, it's going to appear here. Because we only filter something if it appears in an info level message. We can do any kind of custom settings in this case. We can also say if we have an error and it shows not so critical, it's not going to display it. So not so critical, something not so important happened. In this case, also it's not going to be displayed. So you can completely customize to your needs. I was just trying to show you this one. Of course, you can improve it a lot better if you want. Just a few examples. And we can do the same with the handlers. That one is maybe it's kind of same complexity, but the one I wanted to show with CloudWatch, we would need to use Boto3, create the log group, the log stream, all that. Next time we can do that. And I hope this is clear, right? So basically, it's only going to log those messages that fit the filter. And if you use the default logger, it's not going to be affected by this. So edit something is still going to be shown at an info level also, because the root logger is completely separate from the module. So from the module level logger. So this one, oh, where is it? This one. So these settings that we had with the logger add filter and all that, it only applies to that particular logger, but not the module level one. No, not the root level. This logging.info is the same as logging.root.info. Maybe it's clearer if I write it like this. It's just a shorthand if I do this. And probably also, yeah, just a shorthand. Okay. Do you have any questions relating to logging or any of the things that we covered? I think I should have asked earlier already if something is unclear.
I think we can just rewatch once again.
Sure. I think in the beginning, sorry, I think I was really unclear with the first one. Second one, okay, but the first one I was also a bit lost, it seems, with all that with all those constraints, because I actually tried to look for a good solution, but it seems the best you can do is n times m, it seems. Somewhere around that. So yeah, that's a tough one. All right, let's wrap it up for today then.
All right, thank you
Thanks
so
for
much.
joining, and see you guys.
Have a nice
Thank you,
week.
Kevin.
You too. Bye.
Bye-bye.